Hello everyone. In today's lecture, we'll be continuing our journey with vectors, and in the last lectures, we studied what are vectors and how to add two vectors. In the second lecture, and in the third lecture, how we did the opposite thing. We did what did we do? We did that we divided a vector into two vectors by by resoluting them in two components, right? So in today's lecture, we'll further understand how to add vectors when they are not perpendicular. See, in the second lecture, we covered how to add vectors when they are perpendicular or parallel or anti-parallel, but there are some questions in which situation might be like that the vectors are not perpendicular to each other. In the second lecture though, we did a exercise on that. In this lecture, we'll dive more into this aspect. Okay, so without further ado, let's start. And so our lecture is about adding non-perpendicular vectors. Okay, we'll add two vectors, those are non-perpendicular. So see, let's say there are two vectors, naming a vector. This is vector A. This is vector A, and another vector. This is vector. Let's say this is vector B. Okay, this is vector B. So in the lectures earlier, we studied this in this way, that think you are starting from here and you are going there and in this direction also. So what is your final displacement? Your final displacement is from start to the end, right? And this is how vectors work. Displacement is one type of vectors. That's why I give that example that much. But all type of vectors work like this. So the resultant vector will be from the starting point to the ending point, right? So what we get is actually we get a triangle, right? We get a triangle. We get a triangle. Let's say this is R vector. This is R vector. So let's say this triangle has points X, Y, and Z. Okay. So the R vector is represented by this XZ arm of this XYZ triangle, right? So if we get the value of this arm, this is the value of the resultant vector, and if we get the angle of this arm, this is the angle of this vector. As easy as that. So right now we need to carry out the calculation for getting the value and the direction of the arm. To get the value, we need to remember a formula named the cosine formula. You all learned this in earlier academic career, in your career. Okay, this cosine formula, it states that for this XZ arm and for this, let's say this is alpha angle, the cosine of alpha, see the opposite arm for the alpha angle. Which one is the opposite arm? This one, right? XZ is the opposite arm for the alpha angle. So we can remember it by this way. Cosine of alpha equal to adjacent 1 square plus adjacent 2 square minus of opposite arm square divided by 2 into adjacent 1 into adjacent 2. So the opposite will be subtracted. You need to remember that. The opposite will be subtracted. So this one alpha, this one is alpha. So the cosine alpha becomes, the adjacents are xy square plus the another adjacent is yz square minus the opposite is xz square. Okay, divided by 2 into xy and 2 into and yz. So what is xy here? Xy means the value of a vector. What is yz here? Yz means the value of b vector. And what is xz here? Xz means the value of r vector. So what we get here? So cosine of alpha equal to xy means a vector square, yz means b vector, xz means r vector square, divided by 2ab. So if we just go through the calculation, a square plus b square minus r square equal to 2ab cosine of alpha. So right now what are we getting is that cosine of alpha, or the r square, basically we need the r, right? R square equal to a square plus b square minus 2ab cosine of alpha. So we get r equal to root over a square plus b square minus 2ab cosine of alpha. This is the value of the vector, value of the resultant, okay? Value, resultant's value. So how do we get the value? By this triangle. See, the alpha angle, we need to remember what's the alpha angle here. The alpha angle is the angle between the head and tail of the vectors a and b vector. See, this is the head, this is the head, and this is another tail. So the alpha angle is the angle between head and tail, okay? Alpha angle is the angle between head and tail. Now we need also to carry out the the angle of r. So how do we get it? We get it by using the sine formula, okay? Which formula? Sine formula. So remember, to get the resultant's value, we need to carry out the cosine formula, and we for getting the result of the angle, we need to carry out the sine formula. So right now let's use sine formula. So I'll get a copy of the pictures. So I'll remove this. Don't you worry, the slides are already saved, so it's not being deleted. So we need to get this sine, get this theta, right? So sine formula, you have to remember the sine formula as well, which is, if you take any angle sine, you have to divide it by the opposite arm. So when you are taking theta here, sine of theta, you have to divide it by the opposite arm. The opposite arm is this one, yz. So sine theta by yz equal to, if you take this alpha, you need to, what do you need to get? You need to get the opposite one. So sine alpha divided by this r, and assuming you knew this one, let's say this is beta. So if you take this sine of beta, you need to divide it by the opposite arm, xy. So this is not r, this is actually xz here in the triangle. Then we can get the vectors here. Yz means b vectors, the value of b vector. Sine alpha divided by xz means the value of r vector, or the resultant. Sine beta divided by the value of xy means a vector. So these are the formulas, two easy formulas that you have already learned in mathematics. We need to apply this to get the answer, okay? So this is one way of adding non-perpendicular vector. But there are few other ways as well. There are few others well. You might use any of them as per your liking, which one you would like. So there are many of them. Like there are techniques like scale diagram. See, there are techniques like scale diagram. See, here is an example with a vector of 3 Newton. That's a force vector, of course. This one is 3 Newton. And another vector is here, which is how much is it? 5 Newton, right? 5 Newton. Using a scale, you can actually carry out the answer here. Okay, so how to carry out the answer? This is very easy. See, this angle is 60 degree, so this angle becomes 120 degree. Okay, this is our alpha. Now what do you get? Right now you have to take it by scale with 3 inches or 3 centimeters, and then you have to take it by scale with 5 inches or 5 centimeters. Okay, so and you have to take the perfect angle as well. So you have a scale to get that. So that one is 60 degrees, so this one becomes 120. So if the question is given here with 120, you need to get here 60, right? This angle. Then this one will be your resultant. Now to calculate this, how do you calculate? You just put a scale beside the triangle and then calculate with the scale. So this will be the value. How to calculate this theta? How to calculate this theta? You need to put this scale right here in the center, and then you get the theta value, right? So this is very easy if you ever want to do it. But there is a but. We don't normally do it. We don't normally do it. What we do is that we carry out mathematical formulations, because that one is easier and more feasible. Okay, because you have to be very cautious while doing this approach, this scale diagram approach. You have to be very cautious with the fine tuning of the measurement. But with the calculation ones, we don't need to be that much cautious. You need to be cautious while giving it the formula, or cautious when taking the result out from the calculator only. So this is not that much feasible in respect to the others. So technique to calculation using sine and cosine rule, we will use that. Okay, so we will use that only. That's why for this calculation what I need is to take this this one in the next page. So just bear me a few moments here. I'll just take this photo and give it to the next. Okay, and give it to the next page and use our cosine and sine rules. Okay, it will be much easier. So let's assume this is R, and let's assume this is A, and assume this is B. Okay, assume this is B. So right now we will use sine and cosine rules to carry out the, what do you need to carry out? The magnitude of the force, resultant force, and the direction of it. Okay, both of them. So bear with me, using cosine rule. Let's start with cosine to calculate the magnitude. Using cosine rule, see, what do you need? We need R vector. So R equal to root over A square plus B square minus 2AB cosine of alpha. Which one is alpha? This one is alpha. Remember, this one is alpha. Okay, so now root over, which one is A? A is 3 Newton, 3 square. Which one is B? B is 5 Newton square minus 2, 3, 5 cosine of 120 degrees. So right now you need to calculate this one only. So with your with the help of your calculator. 3 square plus 5 square. You need to calculate it while giving the keeping the calculator in degree mode only, not in radian. If you take this in radian mode, you will get an answer, but the answer will be incorrect. Okay, so be aware of that. You need to take your calculator to the proper degree or proper angle. Okay, though this is 7 Newton. So this one will be, how much will this be? This will be 7 Newton. Now we need to carry out the angle as well. So sine rule. What did we learn just now? We learned that if you take any angle sine, you need to divide it with the opposite arm only. So if you take this sine theta, divided it by this one, the B. Okay, and what we know here from this figure is that alpha, we know it properly, it's 120 degrees. So sine alpha divided by this r. So the theta is unknown right now. Sine theta, B is 5 newtons, sine of 120 by r is 7 Newton. So sine of theta equal to 5 into sine 120 by 7. Okay, so 5 into sine 120 by 7, which one is 0.62, and the theta is sine inverse this answer. So I will get the sine inverse of the answer. This is 38.21 degrees. For perfection, you need to mention with respect to whom, because this theta angle is the angle between A and R. Okay, so we just need to mention with respect to the A or with respect to 3 Newton force. Okay, with respect to the 3 Newton force only. Okay, so done. This is it. This is the technique that we can use actually. Okay, and then there is another technique, calculations using vector resolution, that we have learned in the last lecture, the previous lecture. Okay, we have learned how to resolute a vector in two perpendicular axes. Now we can calculate the resultant using that. This calculation is very easy. Very easy means very easy. See, let's assume we have two axes here. Okay, just be a bit attentive and you will get it. There are two axes. This is x axis and this is y axis. Then you need to carry out the resultant of two vectors, naming, let's say this is a vector, this is a vector, and this one has an angle of theta 1. Okay, with x axis, and you need to carry out the resultant of A and B. Let's say this is B vector, this is B vector, and this one has an angle of theta 2 with x axis. So how will the resultant be? How will the resultant be? The resultant will be like this. See, anywhere between these two. Let's say this is the resultant. Okay, so let's say this is R vector with an angle of theta only. Okay, so what do you need to calculate? You need to calculate what is the value of R and what is the angle of theta. These two you need to calculate, nothing else. Nothing else you need to worry about. You need to just calculate this thing only. What is R and what is theta. Okay, So right now, how do we calculate it? See, that is very, very easy. So in the x-axis, there is effects of A and B. Which are the effects? See, in the last lecture, we learned about the resolutions of the vectors. So A vector has an effect of A1, A cos theta 1 in the x-axis, okay? And in the y-axis, it has an effect of A sin theta 1. Remember that we got this from where do we get this? We got this from the adjacent will be cosine, the opposite will be sine. So for A, the adjacent with theta is cosine, the opposite is sine. Cosine and sine. Adjacent is cosine, opposite is sine. For B also, you will get the effect of B in the x-axis, which is, this is B, this is theta 2. So the adjacent will be cosine. So B cosine of theta 2, and the opposite here will be B sine of theta 2. So let me just calculate the total of it. Total resolutions in x-axis is A cosine of theta 1 plus B cosine of theta 2. This is the total resolution or total effect of these two vectors. So the total resultant's effect will be equal to the summation of those two effects. So total resultant effect will be here. And how do you get this? You get this by summing B cos theta 2 with A cos theta 1, and you get two of this summation and you will get perfectly that R cos theta. So this one will be R cos theta, the total resultant, okay? And for the total resultant in the y-axis, or the effect on the y-axis will be R sin theta. And how do we get this? We get this by adding the effects of those two vectors, A sin theta 1 plus B sin theta 2 equal to R sin theta. See, you don't remember you don't need to remember this. You need to remember only this. What is this? This is very easy thing. So to get the R cosine theta, you need to just carry out the summation of A cosine theta 1 plus B cosine theta 2. To get the R sin theta, you need to carry out the summation of A sin theta 1 plus B sin theta 2. So like for like, see, to get cos theta, you need to sum the cos thetas only. To get sin theta, you need to sum of the sin thetas only. So how do you get the R? See, if you take the squares of both equations, equation 2 square plus 1 square, you will get R square sin square theta plus R square cos square theta. And you know what? If you take R square as common between these two, you will get R square into 1, because sin square theta plus cos square theta is 1, so you will get R square. So you will get the R from here, okay? You will get the R from here. And what about the angle? If you divide 2 by A, 2 by 1, so R sin theta by R cos theta, see, R will be cut from the equation. R will be cut. R cuts R, so you will get tangent of theta only. So that's it. Tangent of theta equal to sine theta by cos. So you will get both the resultant's value and the angle as well. However, if you see it for the first time, at the first time it might seem a bit like complicated to you. It might seem a bit complicated to you, okay, for the first time only. But if we do the maths right now, you will get it. It will be very, very easy for you to calculate. So right now we will just dive into some mathematics with this formulation, and it will be very easy. Just believe me, it will be very, very easy. You need to carry out cos theta and sin theta only. Cos theta and sin theta, then you need to carry out this angle and this magnitude. Okay, so let's do some maths right now. So three forces act on an object in this figure. Calculate the magnitude and the direction of the resultant forces. This might come for 4 marks. Okay, so in an object, there are three forces. See, 3 Newton, 2 Newton and 1 Newton. 3 Newton, 2 Newton and 1 Newton. This one is pretty easier actually. What you need to do is that think about, see, we learned how many forces for 2 forces, but we can do it for 3 and other forces as well. You need to think about, see, these 2 and these 3 are anti-parallel, right? So for anti-parallel vectors, what does the resultant mean? The resultant is equal to the difference, and in which direction? The direction in the which one? The bigger one. So for these 2 only, not this one. See, this one will be here. So if we just redraw this here, so let me just redraw this. Okay, this one, this 2 will be gone, and this 2 will be 3 minus, this 2 will be, sorry, this 2 will be 3 minus 2, 1 Newton. Okay, how do you write it? You can write 3 Newton and the difference of 2 Newton is 1 Newton. In which direction? On the bigger one's direction, 1 Newton. And there is another vector here, see, 1 Newton. 1 Newton. Now we need to calculate the resultant force. Right now, see, this is very easy right now. There are 2 vectors which are perpendiculars one. As, so we'll write as both the forces are perpendicular, so the resultant, see, the resultant will be in this direction. Resultant R equal to root over 1 square plus 1 square, root over a square plus b square. Remember, 2 perpendicular vectors, root over 2 Newton. This one is the, which one is this? This one is the magnitude. What about the direction? So let's see, the direction is theta. So tangent of theta means the opposite divided by the adjacent. The opposite one, see, the opposite will be 1 Newton as well. So this is 1 and the adjacent is 1 Newton. So tangent of theta equal to 1, or theta equal to tan inverse 1 or 45 degrees. So this is the answer. This one is the answer. See how much easy is this if you think like calmly. If you think about, oh my god, there are 3 forces, I can do 3 forces. No, no, no. You can carry out the subsequently, because you can add 2 and then add with the another one. This is easy. It will be easier for this type of things. Okay. So if there are parallel and anti-parallel, add them first and then do the rest. It will be easier for you. Okay. Then next, okay. 3 tugboats are towing an object at sea. The forces and angles between the cables are shown in figure 9 here. Calculate the magnitude and the direction of the resultant force on that object. See, there are three forces. Okay, there are three forces. How much are they? Three tugboats. So three forces. It is 12.5 kilonewton, 11.8 kilonewton, and 8.7 kilonewton. You might now just complain me. How do we get it? We just calculated 2. How to calculate 3? See, these formulations can be done with any number of forces or vectors. I just got you this with two vectors only, but you can do it for 3, 4, 5, 6, let even 100 ones or more than 100. Any number of vectors you can try this with. So what you need to get? You need to get the resultants. Let's assume the resultant is R, which makes an angle theta, okay, with the horizontal axis on the figure. Okay. Then let's assume our three forces here. So let's give them some name here. So let's do it by this font. Okay. Let's see, this is A force. Okay. So theta of A is 25 degrees, or theta 1 is 25 degrees. Let's say this is B force. Theta 2 will be 0 degree here, right? Why? Because it's already parallel to the x-axis. And theta 3, now you need to be a bit attentive here. See, this angle was positive because it can be drawn in anti-clockwise direction. While we talk about axes, in the angles, we have to look at the direction of them, if they are anti-clockwise or clockwise. See, this 35 is clockwise, okay? This 35 degrees clockwise direction. So what you need to do is give it a minus, okay? Minus of 35. So remember this, clockwise angles are negative, anti-clockwise angles are positive. So there is something new, something new to learn in every math. Okay, so you need to be attentive. See, this one is minus 35. Why? Because this is in a, which direction is this from the x-axis? This is clockwise direction. Okay. So the values are gone, and this is C. Let's say this is C. The values are there and the angles are there as well. So you get R cos theta and R sin theta as well. How do you carry this to? Very easy. A cos theta 1, B cos theta 2, C cos theta 3. Okay. So what is A? A is 11.8 cos 25 degrees. B is 12.5 cos 0 degrees. C is 8.7 kilonewton cos minus 35. Okay. You need to carry minus here, and also you need to put this in your calculator. So each step is important right now. 11.8 cos 25 plus 12.5 cos 0 plus 8.7 cos minus 35. So this one will be 30.32 kilonewton. Okay. And how much is r sine theta? See, this is a sine theta 1. For sine you need to sum the sines only. B sine theta 2, C sine theta 3. Okay. 11.8 sine 25, 12.5 sine 0, 8.7 sine of minus 35. Okay. So in the calculator replace every cos by sine and it will be good to go. So 11.8 sine, let me do that again, 25 plus sine 0 will be 0 and 8.7 sine minus 35. It will be minus 3.22 into 10 to the power minus 3 kilonewtons only. So it will be very much less here. Okay. Let me check this calculation. Yeah. Okay. So this will be minus and this will be plus. So how to carry out the r here? So to get r, you need to, let's say this is 1 and this is 2. So 2 square plus 1 square will bring you r square cos square sine square theta plus r square cos square theta equal to 30.32 square minus of 3.22 into 10 to the power minus 3 square. So r square becomes something, it will become something, you can get that from calculator, then r, I will calculate the r straight, 30.32 square plus minus of 3.22 into 10 to the power minus 3 square. It will be 30.32 only. The unit will be kilonewton. See, this is kilonewton, kilonewton, kilonewton. So this will be kilonewton as well. So what about the angle? What about the angle? So to get the angle, see, I'll just remove this. To get the angle, so r sine theta by r cos theta equal to minus 3.22 into 10 to the power minus 3 divided by 32. So we'll get the tan theta here. So tan inverse minus 3.22 10 to the power minus 3 divided by 32. So tangent of theta equal to something, and the theta will be, I got that, tends to 0 degree. Okay. It is minus 5.76 into 10 to the power minus 3, it means close to 0 degree, or with the in the horizontal axis. Okay, 0 degree means the horizontal axis only. Okay, so done. See, so you can carry out the summation of 3 or even more vectors, but in your exams nothing more than 3 will be given, so don't worry about that. Okay, you will highest get 3 vectors to calculate. And how to do the calculation? Just carry out the summation of coses and carry out the summation of sines. After getting those, carry out r and carry out the theta. See, we'll get another here. 2 tugboats are pulling a ship, each with a force of 8 kilonewton and the angle of 40 degree between the cables. So the angle of 40 degrees between this cable and this cable. So this one is 20, this one is 20. See, from the previous one, this is let's say this is theta 1, this is plus 20, but for theta 2, This is minus 20, right? From the previous lecture or previous question, we can learn that. Calculate the magnitude and the resultant of the resultant force. So, how to calculate? Let's assume the resultant magnitude R with an angle theta with horizontal. Okay, this one is easier from the previous one because this is only two vectors. So R cos theta equal to F1 cos theta 1 plus F2 cos theta 2. What are the values? Check them. F1 is 8 kilonewton cosine of 20 degree. This one is also 8 kilonewton cosine of minus 20 degree. Put it in your calculator. Give it to your calculator to calculate 8 cos 20 plus 8 sin 20. Sorry, cos minus 20, which is 15.04 Newton. This is R cos theta. And for R sin theta, this is F2. What happened? This is F2. Sorry, F1 sin only, sin theta 1 plus F2 sin theta 2. For sin we need sin, for cos we need cos. So 8 sin 20 degree, 8 sin minus 20 degree. This should be 0, okay? Sin 20 plus 8 sin minus 20. Yeah, this is 0. So, how to get the value? So, r square sin square theta plus r square cos square theta equal to 0 square plus 15.04 square. Or from here we will get the r equal to 15.04 kilonewton. This is the value. Calculate this, we will get that 15.04 kilonewton. And what about the direction? R sin theta by r cos theta equal to 0 by 15.04, which one is 0 as well. So tangent of theta will be 0. So theta will be tan inverse 0 or 0 degree. So due horizontal. So the resultant force will be due this only, okay, this axis, x axis only. So the resultant will be 15.04 kilonewton and due to which direction? This horizontal direction. Okay, got it? Okay. Three forces act on a single point as shown in the diagram. Find the magnitude and direction of the resultant forces. Okay. So it will be an homework for you. I'll just guide you with the what should I guide you with? There are values are given, okay? So let's say this is F1, this is F2, this is F3, okay? What are the directions here? See, for theta 1, this is, let's draw the x-axis here. For theta 1, this direction is 180 degrees, okay? For theta 2, this is theta 2, this is theta 2. Theta 2 is minus 90 degrees, right? Makes sense? Why minus? Because it's clockwise. This is clockwise, right? Clockwise. And what is theta 3? Theta 3. This is 60. So this will be 30 degree. Of course minus. Why minus? Because this is clockwise. So you got all the values f1, f2 and f3, and you need to identify the thetas or the angles. This is the hard part of it, nothing else. And then what do you need to do? R cos theta, R sin theta. Do it, you will have the answer. This is as easy as that, okay? Do it and you will have the answer. Okay, now the final part of our lecture for today, or the, what should I say, our topics, okay, or the chapter. We need to subtract one vector from another, okay. See, let's assume there are two vectors. This is a vector, this is a vector, and another vector is b vector here. Let's assume this is b vector, okay, b vector. What you need to do is to carry out, the question is, we need to carry out a vector minus b vector equal to what? This is the question. We need to subtract one vector from another. Now, the fun part is, when you subtract one thing from another thing, what happens? Let's say you are subtracting $20 from $100, okay, or pounds, whatever you might say. What happens here? What you do actually, this is $80, of course, you know that, but what do you do actually? We actually add minus of 20 with 100, okay? We actually add minus of 20 with 100. So 100 plus of minus 20, it will be $80. This is the principle of subtraction, okay? This is the basic of it. So we need to apply the basic here. And one more thing, there is no specific rule for subtraction. There is specific rules for addition of vectors only. So we need to carry out this one like additions, like what we did here, okay? So a vector minus b vector, it will become as a vector plus of minus b vector, okay? What you need to do? You need to get the sum of a plus of minus b. So this is b. How do you get minus b? To get minus b, what you need to do is that you need to reverse this b vector and you will get the minus b1. What you need to do is that you need to reverse this vector. How to reverse it? You can reverse it by doing something like this. See, this is b vector and this will be minus b vector. And then you need to carry out, what do you need to carry out? You need to carry out the, this one is not here right now. You need to carry out the summation or the resultant. So the resultant will be from start to end. So this resultant, this one is actually a plus of minus b or a minus b. So you need to remember just one thing. What do you need to remember? You need to remember that you need to just reverse the following vector. Reverse this one and then do the sum of this plus this, you will get the resultant. Easy, okay? If you think it as easy, this is very easy. But if you overcomplicate these things, it will be difficult. Don't overcomplicate this, okay? Just sum up the a plus reverse of minus b, reverse of b actually. So it will be minus b. See, we'll do an example. Figure 10 shows two vectors a and b, okay? This is a, this is b. Determine the magnitude and the direction of the resultant vector a1 and minus b. So there are two figures here. This one is 4 Newton, okay, and this one is 3 Newton in the direction 40 degree. Okay, what you need to do is carry out A vector minus of B vector. How to do it? Just A vector and get the resultant with minus of B vector, nothing else. So how do you get it? We get the A vector here, we get the B vector here, but we need to reverse this one, right? We need to reverse B vector. So we need to reverse B vector. See, this is reversed. So this is A vector and this is the reverse of B vector or minus B. Reverse of B vector means minus of that vector. Now, what are the angle here? We need to get the angle here, right? What is the angle? For B vector, see, if you get it here as well, you'll get it. You'll get it here. And this one is not present here, okay? This isn't present. We need just for the angle calculation. This one was 40 degree. Okay, so this one will be 40 degree as well. Reciprocal angles. Okay, this is a reciprocal angle of this one. So A and minus B. Can't we do the resultant and direction? Of course we can do the resultant and direction right now. Okay, how do you do that? You can use sine law, cosine law, or you can use our resolutions formula or technique. Let's do that with sine or cosine. Using cosine, let's assume R vector as the resultant of A vector plus or minus B vector. So R vector is from head, from the start to the end, right? From head to tail or the start to the end. So this is A vector minus B vector or R vector. So using cosine rule, R equal to root over A square, then minus B's value square. Okay, so do one thing, minus B's value, let it be written like modulus plus 2 of A vector's value to minus B vector's value cosine of alpha. Which one is alpha? Alpha is this one, right? Alpha. So A vector, how much is A vector? 4. How much is B vector? So see, the value of the B vector remains the same while reversing. The value will be same, but the direction will be reverse only. Okay, so the value remains the same, 3 Newton. 3 square 2 4 3 cosine of, so this is minus, okay, minus 2 4 3 cosine of 40. .57 Newton. This is the value, and what is the direction? So what is the direction of it? So let's say the direction is theta. So using sine rule, sine theta, if you take this theta, you'll need the opposite one, that is minus B, but this one is a triangle and triangles don't have minus. Triangle means the what we need to take is the length of this arm. This length will be the magnitude of minus B. So the magnitude is taken here, okay, divided by sine alpha equal to sine alpha by R. So sine of theta, the magnitude of B is 3, we'll get sine alpha, alpha is 40 degree and R is 2.57. So from here you will get theta value. So let's do it like that, sine 40 into 3 divided by 2.57, 48.62 degree with respect to A, right? respect to A. See, that's the answer. These two are the answers here. We'll get the angle and we'll get the magnitude as well. And also, we can do it by the resolution technique as well. So I'll get you a homework. Do this using resolution of vectors. Resolution of vector. What you need to do? You need to calculate this one and this one's value and directions. Okay, that's it. Nothing else you need to worry about. So here it is, our first chapter, units and measurements. Okay, this is done with all the topics, physical units, quantities and units, measurement and vectors within it. Everything is done, and I have solved and talked about all the concepts and all type of maths available. Okay, and now to see the further lectures or to learn more, you can join my online course on physics, English medium physics or A-level physics. I'll give the links in the description and the pinned comments and everywhere, and you can just join me and learn about physics more thoroughly, so that any type of questions that comes in the exams are covered. Okay, you need to just follow me or learn with me, nothing else. Okay, you need to just practice with me, only just learn with me, and give it some time, and you will get proper marks in your exams. Nothing will be difficult. We'll make physics very easy together. Okay, thank you.